Hey guys, this is Anar, your civil pro, and this is the fifth day of the building estimation course. And before starting to watch the video, make sure you like the video because it helps to reach more people. Okay, so in the previous day, we had covered full building estimation up to the plinth level. And if you're watching the video for the first time, make sure you watch the earlier lectures as well. Okay, so then you can proceed. So, like we operate, hope you have practiced the lecture so till the day 4, and let's proceed to the day 5 of the estimation course. Now, we'll start with we have done till this much, right? Up to the plane beam. So we'll start uh, from the columns and then the roof beam, then the roof slab, and then we'll see what are the other things we need to do. As mentioned, I have this, this earlier, so I just marked. So grade slab, definitely we didn't do. We did PCC. So this plinth level PCC was completed, and after that, there will be columns up, up to slab, brick masonry, inside plaster, outside pressure slab, outside paint, inside paint. So this will complete, and let's see what are the things which we can complete after this as well. But first of all, let us complete this part, right? So column up to this for this floor level. So if we just look into the CAD file provided, so first of all, you can just look into the elevation provided. So it is a ground floor plus 1 floor. So G plus 1 building. And if you observe that for the staircase, there are 4 columns. So the 4 columns, actually go up to the headroom portion. So these 4 columns will go to the headroom portion, and the remaining 4 columns will be for G plus 1. So individual floor we will do. So for the G, we'll do up to this 3 meter, up to 3 meter column we'll do, and then on the next part we'll cover in the next floor. Okay. So simply here already we have this for column up to plinth we had done this. So 4.3 plinth beam we had done, and then next our heading will be. Let me just copy this and paste it. So this will be your 4.4. So for column, and just do this column up to uh, ground floor. Okay, slab. So this is the first slab. So column up to ground floor slab. So this will be taken as C1 because only one column is there in the design. The sizes will be the same, and the number will also be this same. Only the height will change. So here height will do a thing. So when we will take the slab, when we take the roof slab, we will take the entire thing. Okay. So the roof slab thickness you can see here is 125 mm. So what we'll do, we'll take 3 minus 125 mm. Okay. So which will equal, we'll stop by calculator here also. So 3 minus 0.125. So it was 2.875. So we take out the column of 2.875 because this portion inside the slab, the RCC will be considered in the beam itself. Sorry, not the beam, your slab itself. So we'll take the columns up to 2.875 meter height. So 0.3 into 0.3, this will be your 2.875. So this will give us the column up to ground floor slab. Now similarly, what we'll do next is the roof beam. So this roof beams will be if we just look into the CAD design, this one. So roof beam, ground floor and first floor. So ground floor and first floor, the roof beams are the same. So okay, so this is the plinth beam, and ground floor and first floor, the roof beams are the same. So then definitely one will calculate one, then we can repeat. And another thing you can see, the length also for the beams also is the same. So the same plan is in the ground floor and the first floor. Here only the placement is different. So I think the placement is different than this particular beam's placement is different. but apart from that, the lengths are equal. So there is no difference in the in this flow. So you can copy and paste most of the things. So the next portion will be we'll do for your beams. So this will do 4.5 will do, and 4.5 will be the roof beam, and you can just GF slab. So ground floor slab, roof beam, we are calculating here. So now this was sorry PB1 and PB2, obviously. Okay, so this was this, and ground floor slab roof beam. So ground floor slab roof beam. Let's see how many types of roof beam we are having here. So B1, B2, and B3, three types of roof beams we are having in this particular building. And B1 is 250 into 400, right? So and B2 is 250 to 350. So B1 is 250 to 400, and you can see B1 in this portion and in this portion. Okay, and in this two portion is B1. So first of all, simply what we'll do, we'll just I'll just copy this one. Okay, copy this very easily, and this will write as B1, right? Sorry, capital B1. So this is B1. Now the length and breadth of the B1, if you just see from the figure, is 250 into 400. So we'll write here 250 into, in place of this 0.3, this will be 0.4. Enter, and this will be the calculation for the B1. And the length of the B1 is obviously different. The total length, as you know, we'll say for the B1, what is the length? Let's calculate here. So simply you just see this is one length here for the B1, and then this into 2. Okay, one this portion and this portion. So this into 2 if we do, then we'll calculate the B1. So it is 4873, right? 4873. So it will be equals to 4.873 into 2. So this will be the B1, and let's see what other sizes we have. We have B2 and B3. So B2 and B3 have the same size. So we'll write here B2, B2, and B3. So now we know one thing, that when you compare this to ground floor slab and the first floor slab, the total length of beam is the same. So the total length of beam is the same. So we already have the total length of the plinth beam. So what we'll do, we'll do equals to this minus this. So we get the remaining length of the beam, and the things we know, 0.25 into 0.35. So this is the size of the PP2 and PP3, 0.250 into 350. We know that. So this is the size, and the multiplication we'll get from here, the multiplication. So we got the roof beam of ground floor slab. So same will be for the first floor slab also, but when we go to the first floor slab, we'll see. So now we'll do for the ground floor slab. So first floor slab, these two things. So copy this and we'll paste it here. So this will do 4.6, and this will do 4.7, right? And you can have different type of arrangements. I'm just showing a type of arrangement here, and we can modify the arrangements as per our choice. Okay, so this will be for the first floor slab here, first floor slab, and roof beam also for the first floor slab. So now for the first floor slab also, the height and all will be the same, and for the beams also it will be the same for the first floor, since the design is the same. So now there will be one additional thing for column up to for headroom columns, right? So this will be column in headroom. So headroom is the portion of the staircase. So if you just observe in this particular your particular diagram, that the staircase, we have four columns which will go up in the headroom portion. So now we need to provide the headroom portion, and headroom portion height. Number of columns is four, and all the columns are same C1. And the headroom height we obtain from here, that is 2.4. So we take the full height here because we intend to provide and different type of your, let's say, tin or any other material, or this temporary structure, or we can provide concrete also. But here let's consider 2.4. So 100 or 125 extra won't hurt us. So just take this and just take this one, and in this thing, number will be 4, and the height will be your 2.4. So height will do as 2.4 meter. Bedroom height 9 feet, 8 feet. Generally it is there. So this is the headroom height. So column for headroom we have calculated. So now we can see that we have safely completed this column up to slab level. Actually, column we can do this column and beam, right? Because there is beam also. There is below beam or not? No. So column and beam up to slab level RCC we have completed. So the next thing is your brick masonry. Now, brick masonry is generally of in majority of the buildings, depending on the location of the building where you're making, is of one or two types. In some places you'll find the outer wall thickness is like 10 inches and the inner wall thickness is 5 inches, or outer wall thickness is 9 inches and inner wall thickness is 4 inches. Like this you will find. In some places you'll find that all the outer wall or inner wall are the same thickness. Actually, what we should do, as per my opinion, you can make the outer wall and inner wall thickness as the same, 4 inches or the 5 inches, whatever the thickness of the brick, because the structures which you are making are the frame structures, and the brick is only acting as a partition. So you can have 5 inches wall easily mainly for the initial building. If you are concerned with like additional safety purposes, you can go for 10 inches wall, 10-inch wall, or this thicker wall. No problem in that. But in this particular structural design, what I have considered, if you see the architectural plan as well, all the walls are the same thickness. This is a small residential building. All the walls are same thickness of 125 mm, or you can see 5 inches. So the entire design of entire wall calculation will be for the 5-inch wall. So we can say that if you just compare the ground floor plan, and this is the ground floor plan and the first floor plan, I can see that only there will be very minor changes, because you can see only this wall is shifted to the column side in the first floor, and this is in this side in the ground floor. So only the minor changes. Toilet is also in the same position, you can find, and only this wall is changing. So only this much calculations will be changed. So we'll do the calculation for the wall in the next class, and till then make sure you practice and just enhance your concepts as well. Just revise your concepts, and if any doubt, any kind of doubt, just make sure you write it in the comment section. Thanks for watching. Keep learning, and bye bye.